In this video, I'll show you how to find the vertices and foci of an ellipse whose center is at the origin. The question reads, find the vertices represented as v and the foci, f, for the ellipse 16x squared plus 36y to the power of 2 is equal to 576, whose center is at the origin 0 and 0. I'm going to give you a second to analyze the equation. And notice that this equation, the right side isn't equal to 1. Whereas in the standard equation of an ellipse, there's always one side equal to 1. So the first thing that I'll do to this equation to make it look like this one is divide both sides by 576. And what that will do is make the right side equal to 1, and that will make us one step closer to creating our equation. If I divide both sides by 576, here's what I get. I know the right side becomes 1. And on the left side, we have 16 over 576. We'll use our calculator. 16 divided by 576 gives us 1 over 36. So we have x squared over 36 plus 36 divided by 576 gives us 1 over 16. So y squared over 16. At this stage, you should also notice that the larger of these two denominators, 36, and which will later represent our a term, is underneath the x variable. This tells us that the major vertex for this ellipse is horizontal, not vertical. The opposite is true if the larger number is underneath the y term. The reason why having the equation in this format helps is because now we can identify our a and our b term. To identify our a term, we have a to the power of 2 is equal to 36. Look, I'm just matching these. So a to the power of 2 is equal to 36. Therefore, a is equal to plus minus 6. Similarly, b to the power of 2 is equal to 16. And the square root of 16 is equal to plus minus 4. What are they looking for? They want the vertices v and the foci. To find the vertices, what we have to do is understand what we are dealing with here. We are dealing with an ellipse whose major vertex is at the horizontal. This means that it's wider this way than it is this way. Our a value will therefore serve as our vertices. We have a vertex at minus 6 and 0. Let's call this point minus 6 and 0. And we have a vertex at positive 6 and 0. This point right here. To find our focus for this side and this side, what we have to do is use the following formula, where c is equal to the square root of a to the power of 2 minus b to the power of 2. C actually represents the distance from the center to the two foci. So if I find out what my c is, I found out the distance from here to here, and that can tell me what my focus is for both of these sides. Let's go ahead and do that. We have c is equal to the square root of 6 to the power of 2, and it doesn't matter whether you use positive or negative 6, it's going to be squared anyway, minus 4 to the power of 2. 36 minus 16, the square root of that is equal to 4.5. And this is plus minus because you're square rooting a positive number. There's a possibility of plus and minus. This means that this point right here is 4.5 or negative 4.5 and 0. And this point is positive 4.5 and 0. So we just found exactly what they wanted us to find. We found the vertices and we found the foci. And so there you have it. That is how to find the vertices and foci of an ellipse whose center is at the origin.